For nearly 5 decades, the Voyager probes have ventured through the vast reaches of space, offering us groundbreaking insights into regions of the cosmos once thought unreachable. While it's well known that these legendary spacecraft have crossed the boundaries of our solar system, the data reaching Earth from interstellar space isn't always what scientists expect. In fact, things took a surprising turn when Voyager 1 suddenly began transmitting bizarre, jumbled signals back to Earth, a development that left NASA experts baffled. The data was so unusual, it was labeled as abnormal. So what exactly happened to Voyager 1? Did the aging probe stumble upon something so strange that it scrambled its instruments? Or is this simply a case of even the most resilient technology finally reaching its limit? Stick around to find out the real story behind this extraordinary cosmic mystery. It all began with a bold idea. Today, the James Webb Space Telescope is peering deeper into the cosmos than ever before, unlocking the universe's oldest secrets. But back in the 1960s, the situation was quite different. At the time, sending a spacecraft to the outer solar system seemed nearly impossible. The reason? Jupiter, Saturn, and the other distant planets were so far away that any probe would need more fuel than a rocket could realistically carry into space. The thought of closely studying the 4 outer planets felt like pure science fiction, until a man named Gary Flandreau entered the picture. As a doctoral student working at NASA's Jet Propulsion Laboratory in Pasadena, Flandreau was assigned to find a way to make such a mission faster and more efficient. Then, in his small office, he recalled a fascinating phenomenon observed during Neptune's discovery. Whenever Uranus passed by its outer neighbor, it would momentarily accelerate before slowing down again. Similar effects had already been seen with comets. This led to a groundbreaking idea: could spacecraft use the gravity of planets to slingshot themselves forward, saving fuel and cutting travel time? The concept of gravitational assist was born, and space exploration would never be the same. Flandreau gave this question serious thought and concluded that not only was such a mission possible, but that a spacecraft could actually gain momentum by performing multiple close flybys and gravity assists around the planets. This approach could allow a probe to visit all the outer planets in a single journey, cutting down travel time by nearly 20 years. However, this idea wasn't just about physics, it also depended on a rare planetary alignment. Fortunately, Flandreau discovered that in the mid-1980s, a unique alignment would occur. All 4 gas giants and Pluto would be on the same side of the Sun and unusually close to one another. That alone was remarkable, as such a configuration only happens once every 175 years. This insight marked the beginning of the Voyager missions. With the clock ticking, engineers and scientists began crafting a mission plan. Initially, the concept included launching 4 spacecraft in 1977 to explore the distant, mostly uncharted outer planets. But with a price tag of $900 million, the U.S. government, no longer focused on space exploration after the moon landing, found the cost too steep. As a result, the mission was scaled back to just 2 probes, and the objectives were narrowed. The revised plan focused only on Jupiter, Saturn, and Saturn's moon Titan, while potential flybys of Uranus and Neptune were put on hold. It's hard to imagine how NASA officials and the government would have responded back then if someone had predicted that the Voyager probes would one day journey into interstellar space. What we do know is that the spacecraft had to be designed to endure the challenges of deep space for a very long time. Modeled after the earlier Mariner probes, Voyager 1 and Voyager 2 were originally built to last just 10 years, a duration that seemed incredibly ambitious at the time. To withstand the intense radiation near Jupiter, engineers equipped the most sensitive components with specialized shielding. Meanwhile, all critical systems, including the onboard computers, data storage units, and communication devices, were installed in duplicate to ensure reliability. These systems were built with technology that, by today's standards, feels almost primitive. To put it in perspective, the computers on board the Voyager spacecraft can process about 80,000 instructions per second. Compare that to even an outdated smartphone sitting in a drawer today, it likely handles over 15 billion instructions per second. But while our old phones can't survive the vacuum of space or transform our understanding of the cosmos, Voyager could, and did. What the Voyager probes discovered. On August 20, 1977, the long-awaited launch finally took place, But surprisingly, it wasn't Voyager 1, but Voyager 2 that was the first to lift off from Cape Canaveral spaceport in Florida. Its twin, Voyager 1, followed shortly after, launching on September 5. Despite launching second, Voyager 1 had a shorter route to Jupiter and Saturn, allowing it to catch up and fulfill the promise of its name by arriving ahead of its sister probe. Indeed, in March 1979, Voyager 1 reached the Jupiter system and began transmitting breathtaking images of the giant planet. These included not only the swirling, storm-filled atmosphere but also the first ever recorded lightning bolts on another planet. However, the real surprise came from Jupiter's innermost moon, Io. Once believed to be a frozen, inactive world, the Voyager images revealed a vibrant and geologically active landscape. Later analysis confirmed that Io is in fact a hypervolcanic moon, teeming with ongoing eruptions. Equally fascinating were the flybys of Europa. Detailed images of its frozen surface, along with readings of its density and heat levels, provided the first clues that a subsurface ocean might exist beneath its icy shell. Even today, Europa remains a prime candidate in the search for alien life. Another highlight was Voyager's close encounter with Saturn's moon Titan, passing just 6,500 kilometers above its surface. The data revealed a thick nitrogen-rich atmosphere laced with hydrocarbons. At the time, it was only suspected that methane and ethane existed in liquid form on Titan's surface, but that suspicion has since been confirmed. Today, we know Titan is dotted with methane lakes and flowing rivers. Voyager 2 delivered stunning revelations about the Saturn system. As we marveled at the breathtaking images of Saturn's rings and its many moons, an unexpected and troubling event occurred. A serious technical malfunction threatened the mission. Just after using Saturn's gravity to propel itself toward Uranus and Neptune, Voyager 2's camera suddenly became jammed. Although engineers managed to resolve the issue, the exact cause of the glitch remains unknown to this day. Despite that scare, Voyager 2 successfully reached Uranus in January 1986. There, it made groundbreaking discoveries, including 11 previously unknown moons. It also revealed that Uranus, long thought to be a gas giant, is in fact better classified as an ice giant. Beneath its gaseous outer layer lies a dense mantle of water ice. Even more surprising was Uranus's magnetic field. With 4 poles and a skewed, corkscrew-shaped structure, it defied conventional expectations. One of the most mysterious findings came from Uranus's moon Miranda. Its surface, a chaotic patchwork of sharp ridges, deep canyons, and strange formations, stunned scientists. No other known celestial body exhibits such a bizarre, mosaic-like terrain, and its origin remains a mystery. Then came Neptune. In August 1989, Voyager 2 gave us our first close-up view of the distant planet. Like Uranus, Neptune turned out to be another ice giant with a similarly strange magnetic field. This marked the beginning of an entirely new chapter, a journey into regions of space never explored before. By contrast, Voyager 1 had already veered off toward the outer solar system back in 1980. On August 25, 2012, it became the first human-made object to enter interstellar space. Voyager 2 crossed that same boundary in November 2018. Together, these two legendary spacecraft revealed that interstellar space is far more complex and dynamic than scientists once believed. Rather than being an empty void, this distant region is filled with the interstellar medium, a mix of gas, dust, and cosmic radiation. It turns out this medium plays a much more significant role in shaping our heliosphere, the Sun's protective bubble, than previously understood. For instance, the interstellar medium exerts up to 10 times more pressure on the heliosphere, leading to increased interactions between the two regions. Additionally, on this side of the heliopause, the outer boundary of the heliosphere, there exists a vast magnetic barrier that serves as an extra shield against cosmic radiation. The data collected by the Voyager probes about interstellar space has proven to be both groundbreaking and one of a kind. However, an unexpected incident occurred 3 years ago that initially left scientists completely puzzled. Voyager 1 began transmitting erratic and seemingly nonsensical telemetry data. What made the situation even more perplexing was that the spacecraft itself continued operating normally, with its main antenna still correctly oriented toward Earth. It took weeks of investigation before researchers could unravel the mystery behind the bizarre data stream. Despite wild theories circulating online, the spacecraft hadn't been intercepted by aliens.